We're in AM Unit 4L8, Logarithmic Equations, and if you look on your guided notes, we're ready to jump in. Step 1 is going to be to condense the logarithms on either side of the equation. We're going to be using those three properties that we looked at already. So you have your product property, your quotient property, and your power property up here. Then we're going to use the one-to-one property just like we did in the previous section, and that's going to say if you have log base b of x equals log base b of y, then x equals y. Those are your arguments. So once you get them matching, you can just set your two arguments equal to each other. Okay, the other thing I want to talk about is step 3 says solve and check for extraneous solutions. So what is an extraneous solution? We've checked for these before, and when you would plug it in, if you got an answer that wasn't true, then that was extraneous. Well, now that goes beyond, or we're going to go beyond that just a little bit. First of all, an extraneous solution is one, yes, if you plug it in and your two sides don't match, obviously that's extraneous, but there is another thing. If that number results in a non-positive argument, I spelled argument wrong, argument. Now, this is your argument right there in both of them. That's your argument, that's what that's called. So if you plug a number back in that you got for an answer and it makes that 0 or a negative number, because remember 0 is not positive, 0 is, it has no sign. So if it makes your argument 0 or negative, why? Well, because that's how logarithms were conceived. All right, that's just the rule of the game. So let's look at number 1. Fortunately, there is no condensing to do on this one. We have a single log base 3 over here and a single log base 3 over there. So all we're going to do is take the argument, 7x minus 1, and set that equal to the other argument, and then solve. We can subtract 5x from each side, so that's going to give us 2x minus 1 here and 17 there. Then we can add 1 to each side to get rid of the minus 1. So now we have 2x is equal to 18. And then we divide both sides by 2. So x is equal to 9. Now to check it, you go back up here. If I plug 9 in there, 7 times 9 is 63, minus 1 is 62. That is a positive argument, so that's good. Now let's see if it makes the same thing over here. 5 times 9 is 45. 45 plus 17 is 62. So the answer checks, it is valid, and we can move on to the next problem. Okay, for number 2, we have natural log of k squared minus 4k is equal to natural log of k plus 14. They are already condensed, so we don't have to do that. So we're ready for one-to-one property of argument equals argument. So k squared minus 4k is equal to k plus 14. So now we're just solving. You see that you have a quadratic, so 0 product property is going to be my first choice. Let's get a 0 here. We're going to subtract k and subtract 14 from each side. So what that's going to be is k squared. All right, minus 4k and a minus k is minus 5k. Minus 14 equals 0. And factoring the trinomial, k and k, since this is a minus sign, you know you're going to have one of each. Now, what two numbers multiply to give you negative 14, but add up to give you negative 5? That's going to be negative 7, positive 2. So you would set k plus 2 equals to 0 and solve. That's going to give you k equals negative 2. K minus 7 equals 0 is going to result in k is equal to 7. So your answer pair here is negative 2 and 7. And don't forget, you would need to plug them in and check them. I did. There were no extraneous roots, which means it did make a true statement. Both of these balanced. And you did not get a non-positive number, 0 or a negative number, for your argument. Okay, let's move on. Okay, for number 3, now we are going to have to condense this on the left side. It's added, so we're using our product property. And that tells us that you can multiply the two arguments together. Now I'm kind of going to do a step in my head here, so watch what I'm doing. When I combine those, when I do 4c plus 3, the logs are going to equal, so I'm just going to go ahead and apply my one-to-one property and set my arguments equal to each other. Now we're ready to solve. So 4c plus 12 is equal to 8. And we're just solving the equation. Now let's subtract the number that's attached to 4c. So that's going to be minus 12 on each side. I have 4c is equal to negative 4. Divide both sides by 4. And c is equal to negative 1. And yes, you would want to plug this back in and check it. Now let me show you this, how you check this. If I plug negative 1 in here for c, what is negative 1 plus 3? Well, that's 2. Now remember, according to your product property, you can multiply your two arguments together. So is log 8 equal to log 8? Yes, it is, and it is not a non-positive number. So you're good to go. Okay, here's number 4, and the first thing I do is I look to see that all my logs have the same bases. Now most of the ones you're dealing with right now, they are going to have that, but it is possible in the future where you will not have the same bases, and that's a whole new problem. So I want you in the habit of checking that first. Are all my bases on my logs the same? And they are. So now we need to condense both sides of our equation. Let's focus on this first. We have a subtraction sign, so that is your quotient property, right? So we're just going to take the argument of the first, which is w plus 6, and put that over the argument of the second log. All right, now over here, I have a coefficient in front of my log. So that means I'm going to take it and swing it around over there. That becomes my exponent, okay? So what is, oops, that's 1/3. What is 8 to the 1/3? Remember, the denominator is your index. You can convert this again into a radical and get the cube root of 8, which is 2, okay? So let me just go ahead and, you can come down under it, or you can just like strike through it and put a 2, okay? 8 to the 1/3 reduced down to 2. Now, we just have a simple equation. I need to get rid of my denominator, so I'm going to multiply both sides by 5w minus 3. These two cancel out, so now I have w plus 6. I'm going to distribute this one and get 10w minus 6. So let's solve. I would subtract w from each side, and that's going to give me 6 is equal to 9w minus 6. Then add 6 to each side. So 12 is equal to 9w. Divide both sides by 9, and you get w is equal to 12/9, which reduces down. 3 will go into both of those to 4/3. And if you plug it in, it does make a true statement, and it also does not make a non-zero or a non-positive argument. So you're good to go. Okay, here's number 5, and I have checked. Both my logs have the same base, so I'm good. Now this is condensed and simplified, and I know I'm aiming to go 1-to-1 with it, so let me just go ahead on my next step and write down 4p plus 3. Okay, now over here, to condense this one, and I'm going to come over here on my scratch page, you're going to have 16p to the 4th to the 1/2 power. This number becomes the power of your argument. Now what does 1/2 power mean? Well, it means the square root of this base. Now what's the square root of 16p to the 4th power? 4p to the 2nd. Okay? So now we're here, we are ready to put this in standard form. It is quadratic, so when we put it in standard form, I'm just going to subtract 4p and 3 from both sides. That's going to move it, so I'm going to have 0 here equals 4p to the 2nd minus 4p minus 3. And to solve the equation, we are going to use the AC method on this one. Do y'all remember that? So since I have a coefficient in front of here, what I'm going to do is multiply A times C. 4 times negative 3 is negative 12. And now I need a pair of numbers that multiply to give me negative 12, but add up to give me negative 4. Well, that's going to be negative 6, positive 2. If you can't think of it right off the bat, you're just going to have to list all the factors of negative 12 there. All right, now for the AC method, remember your goal is to split the middle and then factor by grouping. So I'm going to split this middle term. I'm going to have 0 equals 4p squared. I'll do minus 6p plus 2p minus 3. Then we're going to factor by grouping. So when I take the greatest common factor out of here, that's going to be 2p. So I have 2p minus 3 plus, all right, now there's no greatest common factor here. So remember, what you do is you factor out a 1 because you have to have a term there. You have to have a number. And that's not going to change that factor. All right, now 2p minus 3 is my common factor. So I'm going to put that in my first set of parentheses. It really doesn't matter whether you put that in the first or the second. That's just how I do it. And I have 2p plus 1. So now we are ready to take each one of these and set it equal to 0 and solve it. So I'm going to come over here. If I do 2p minus 3 equals 0, that gives me 2p equals 3. Divide by 2. So I have p is equal to 3/2. And then if I come over here to do the other one, 2p plus 1 equals 0. Subtract 1 from each side. 2p is negative 1. So p is negative 1/2. So my two answers are, put your lowest one first, negative 1/2 and 3/2. And I did check both of them. I'm not going to go through the process here, but I filled both numbers in and checked them. They make an equivalent equation, and neither one makes a non-positive argument. So I'm good to go with negative 1/2 and 3/2. Okay, let's look at number 6. 2 times the natural log of a plus 1 is equal to 3/2 times natural log 80 minus natural log of 5. So first of all, let's condense each side. All right, over here I'm going to have a plus 1. Remember, this becomes an exponent. So you have a plus 1 squared. Now, remember, when you square a binomial, you have to expand it. So what you're actually going to do is a plus 1 times itself. And then when you FOIL this, you're going to get a squared plus 2a plus 1. Okay? So we've got that side simplified. Now let's come over here. First, I'm going to go inside the parentheses, or you can swing it around first if you want to, but I'm going to simplify this. This is a subtraction, so when you divide 80 by 5, what do you get? 80 divided by 5 is 16. So now I can swing this around. What I'm going to have is 16 to the 3/2 power. Now remember, that means what? The square root of, this comes around and becomes the index, 16/3. All right, and if you do that out, do the math out, that's going to be 64. So here's where I am now after I've condensed and done the one-to-one property. Subtract 64 from each side, and you're going to get a squared plus 2a minus 63 equals 0. We have a trinomial to factor. There's no coefficient in front of the first term, so it's just a simple unfoiling. You're going to have a and a. You're going to have a plus and a minus. The pair of numbers that will multiply to give me negative 63, but add up to give me positive 2, is going to be a plus 9 and a minus 7. So we're going to take each of these. A plus 9 equals 0. A minus 7 equals 0, and solve it down. So I get a is equal to negative 9 and a is equal to 7. All right, so let's check them. If I take negative 9 up here and fill it in for a, what does that give me for an argument? It gives me negative 8. That is a non-positive argument So -9 is an extraneous solution. Now, if I take 7 in up here and do all the math, I promise you, it does check out. But I just want you to see, there are times when you will get one that will not work. So you always need to check. I did check every single one, even though I didn't do it on camera. I did do it on scratch paper before I worked it. So your answer here is only the 7. Okay, so on the first page, every problem we had was a type 1, and it was a log to log. You had a log on both sides. On the second page, you're going to have log to number, and we work it a little bit differently. So you have to analyze it and memorize the 3 steps up at the top of each page. All right. So for a log to number, your 3 steps are: you condense and isolate the logarithm, you rewrite the equation in exponential form, and then you solve and check. Okay. So the logarithm is isolated. Now, how do you rewrite this in exponential form? Think back. The base of your log becomes the base number, the base of your exponential. This number over here becomes your exponent, and the argument goes over here. Now you don't have any logarithm. All right, 2 to the 7th power, you can find that out. That's 128. Now you have an incredibly simple equation to solve. Add 4 to each side, gives you 132 is equal to 3x. Divide both sides by 3, and you get x is equal to 44. If you plug this in and check for extraneous solutions, you will see that it checks out. So that's all of number 7. Okay, number 8 is natural log 2a is equal to 9. So we definitely have a type 2, a log to a number. Our logarithm is isolated, so we're ready to convert it to exponential. Now to convert it to exponential, I need to know this base number down here. What is that? Well, if you remember when we talked about the definition of a natural log, what that actually is what? A log base e. All right? So now we're going to have e to the 9th power is equal to 2 times a. You're definitely going to want to use your calculator for this. So just punch in e to the 9th power, and that is going to give you 8103.0839 equals 2a. And we're just going to stop at, there's no need to go further than 4 decimal places. Then we're going to divide both sides by 2. So a is going to be equal to 4051.54. And we'll just stop this one at 2 decimal places right there. Okay, let's look at number 9. I look at my problem and I see that I have a log equals to a number. So I'm using a type 2 problem. All right, first I want to isolate my logarithm. Now this part right here is your logarithm. 5 is attached to it, so I need it to go to the other side. So the first thing I'm going to do is add 5 to each side. So now I have log base 6 of w plus 7 equals 2. Now I'm going to convert it to exponential form. I'm going to take my base, I'm going to swing over there for the exponent, equals to my argument, and I don't need that in parentheses. Okay, 6 squared is 36, and w plus 7. Now I'm going to subtract 7 from each side, so I get w is equal to 29. Now let's check it, because I want to show you how you would check these. So if I fill this in, log base 6, 29 plus 7 is 36, minus 5 equals -3. Is that true? Well, you're going to put this into your calculator. A log base 6 of 36 is, log base 6 of 36 is 2. Is 2 minus 5 equal to -3? Yes, it is. So the answer checks. It does not create a non-positive argument, so your answer is good to go there. Okay, let's look at number 10 here. I have 2 times log base 9, k squared plus 2k plus 4 equals 5. We do identify that we have a type 2, we have a log equals a number, and our first step is to isolate the logarithm. Now that means we need to get rid of everything that's attached to the log, and this is my log. So how do I get rid of 4? Well, I'm going to subtract 4 from each side, and that's fixing to give me 2 times log base 9 of k squared plus 2k equals 1. Okay, now what to do with the 2? In the previous section, in log to log, our first step was to condense. Well, we are not condensing here, we're isolating. So isolate means you get rid of it. How do you get rid of something that is multiplied by something else? Well, you divide. So we are fixing to divide both sides by 2. Now what that's going to give us, these 2's cancel out, so I'm going to have log base 9 of k squared plus 2k equals 1/2. All right. Now we are ready to convert to exponentials. I'm going to take my base, which is 9. I'm going to raise it to this exponent. So now I have 9 to the 1/2 equals k squared plus 2k. All right. What is 9 to the 1/2? Remember, that's the same as a square root. So the square root of 9 is 3 k squared plus 2k. All right, let me come up here to continue working. The first thing you need, now you're ready to just solve the equation, and you see you have a quadratic. So let's subtract 3 from each side before I move up here, and that is going to start me off over here with 0 is equal to k squared plus 2k minus 3. All right, to solve that quadratic, I'm going to factor. And this has an a equals 1, so it's just unfoiling. I need 2 sets of parentheses. This is going to be k and k. I need a pair of numbers that will multiply to give me -3, but add up to give me +2. It's going to be plus 3 minus 1. All right, we'll take each factor, set it equal to 0, and solve. So I'm going to subtract 3 from each side. I get k is equal to -3. I'm going to add 1 to each side. K is equal to 1. So my final answers are -3 and 1. And if you plug them both in, they both work and they do not give you an extraneous root. So you're good to go. Okay, so number 11 here, we've got log base 4 of 2v plus 3. Log base 4 of 2v minus 3 is equal to 2. Before we see that we do have a type 2, it's a log to a number, and before we can isolate our logarithm, we've got to combine it. We need it into 1. So this is a plus sign. I am going to use the product property. So I'm going to go to log base 4 of 2v plus 3 times 2v minus 3 equals 2. Okay, you can use your difference of 2 squares formula to multiply these, or you can FOIL it, however you want to do it. When you multiply those two things together, what you're going to get is 4v squared minus 9. And if you want to know where the middle terms went, well, if you FOIL it, -6v and +6v are going to subtract out. So that's why you end up with this. Okay, equals 2. Now we're ready to go exponential. So I can do 4 to the second power is equal to 4v squared minus 9. 16 is equal to 4v squared minus 9. And ready to solve, I would add 9. There's other ways to do it. I would add 9 to each side. So now I get 25 is equal to 4v squared. And I'm going to come up here. So at the point that I have 25 is equal to 4v squared. Since both of these numbers are perfect squares, the square root property is going to be ideal, and I would go ahead and get them both on the same side. So now I have v squared is equal to 25 over 4, and I'm going to take the square root of each side. So I have v equals, now remember, when you take the square root, you have to do plus or minus 5/2, all right? So if I have -5/2 and +5/2 as possible answers, Now when I come up here to look at my logs, first let's check the -5/2. That's fine here, but if I put, and I don't even have to look at the number, if I put a negative number in here and then I subtract a number, that number is going to stay negative. So that means my argument is going to be negative, and that's a no-go. So the only answer that works here is the 5/2. Okay, let's look at number 12 here. Now, I do have two natural logs over here and a number. So I can't, you know, go into my steps until I get these two combined. All right, I can't combine these two until I condense this one. So I know I told you, you know, we're not condensing, we are isolating. Well, you can't isolate until you get them combined, and you can't combine until you get this condensed. So that's why I'm going a little bit differently on this one. All right, remember a natural log is log base E. So I'm going to go ahead and change that to base E. This is going to be 27 to the 1/3 power. All right, now over here I've got log base E of x minus 5 equals 4. All right, 27 to the 1/3 power is actually the cube root of 27, which is 3. So now I have log base E of 3 plus log base E of x minus 5 equals 4. Okay, to combine, now we have addition, so that means we can use our product property. So now I'm going to have log base E of 3 times x minus 5 equals 4. So this is log base E of 3x minus 15 equals 4. All right, let's come over here to continue working so you can see. Now I'm going to take my base to the 4th power. So this is e to the 4th power is equal to 3x minus 15. And you will need your calculator for this because we're going to get into decimals because we have an e. So let me check my notes. All right, e to the 4th power is 54.5982 equals 3x minus 15. Now when you add 15 to each side, what's that going to give you? 69.5982 equals 3x. Then we're going to divide both sides by 3. So x is equal to 23.20. And you can fill that in, use your calculator, and you will see that it checks. So you're all good there. Okay, so number 13, I have log base 2 of n minus 3 and log base 2 of n plus 1 is equal to 5. I see that it's a type 2, it's a log to number, but I'm going to have to combine these two logarithms before I can convert it to exponential. So since they're added, this is going to be a multiplication. So I'm going to do n minus 3 times n plus 1 equals 5. All right, let's go ahead and foil these two together. N times n is n squared. Now when I do n times 1, I get positive 1n minus 3n. So let's just go ahead and do the addition. That's going to be minus 2. And then my last one, my L, is going to be plus or minus 3. All right, now we're ready to convert to exponential. So here's my base, here's my exponent, equals n squared minus 2n minus 3. 2 to the 5th power is 32. And then when I subtract 32 from each side, I'm going to get n squared minus 2n minus 35, okay? And then I'll come up here because our next step is going to be to factor this. Okay. We're just going to unfoil it because we don't have a coefficient. I need a pair of numbers that will multiply to give me negative 35, but add up to give me negative 2. And since it's the second sign is a minus sign, it's going to be one of each sign. All right, and that's going to be negative 7 and positive 5. Okay, so now we would set each one equal to 0. So I'm going to get n is equal to 7 and n is equal to -5. So my answers are -5 and 7. Now let's check them. If I take -5 up here, well, -5 minus 3, that's going to be a negative argument. So that's a no. And it's also going to do the same thing here. It's going to leave me with a negative argument in my original problem. So the only answer, the only correct answer is 7 here. Okay guys, last one, number 14. And we have log base 2 of c squared minus log base 2 of 3c minus 5 equals 2. Obviously it's a log to number type problem. So the first thing we want to do is condense this or combine these two. All right, they are subtractions, so that's going to be your quotient property. So we have log base 2 of c squared over 3c minus 5 equals 2. All right, now we can convert to exponential. So 2 to the second power, let's just go ahead and do the math there because that's pretty easy. That's 4, but that's where I got that, from 2 to the second power, equals, all right, this fraction here. So I have c squared times 3c minus 5. All right, so how do you solve? Well, first let's get rid of this fraction by multiplying by the denominator on both sides. So 3c minus 5. All right, when I distribute the 4 right here, I'm going to have 12c minus 20 is equal to, now these two cancel out, so I have c squared. All right, quadratic equation. Let me try for zero product property. So I'm going to need to move all this over here. So I'm going to subtract 12c from each side and add 20 to each side. So that's going to give me 0 equals c squared minus 12c plus 20. And we're going to come up here. Okay, this is a trinomial. It does not have a coefficient in front of the first term, so it's going to be a simple unfoiling problem. Since this is a plus sign, my signs are the same and they're going to be whatever this is. So I'm going to have c minus, c minus. Now for that other number, I need a pair of numbers that will multiply to give me positive 20, but add up to give me negative 12. And that is going to be 2 and 10. All right, when I solve both of these, if I do c minus 2 is equal to 0 and c minus 10 equals 0, well, I'm going to get c is equal to 2, c is equal to 10, and I want to look up here and check to be sure that it's not going to create a negative problem, and it will not. So both of those check out. You're good to go. That's the end of this lesson in Unit 4. Great job.